I'm now moving on to the homework questions on page 175 to page 176. And for these homework problems, I need to find the derivative of the following functions. Now for my very first problem, I have y equals to ln of x times root x minus 1. So inside my ln function, I have two functions here, x times root of x minus 1. And for these kind of problems, I need to get to the habit of using ln properties and breaking this problem apart. So the kind of ln properties that I'm referring to are things like ln of a times b. And this is the same thing as ln a plus ln b. So from pre-calculus 12, this is very similar to the log properties. So log AB is the same thing as log A plus log B. So these properties are very similar. And another property that I will be using later on in this question will be ln of A to the power of B. And whenever you have an exponent, you can actually kick that exponent to the front, and that would be B times ln A. So these are some of the logarithmic properties I'll be using throughout this homework video guide to solve some of the problems that we have here. Okay, so once again, going back to the original problem now, I have ln of x times root x minus 1. So if I want to use my very first property right here, I have to recognize that this x is like my a, and this root x minus 1, that's like my b. So if I use my logarithmic properties here, I would break this up by doing ln of x plus ln of root x minus 1. Okay, so I will continue to simplify this. So I'm not taking the derivative just yet, but this is ln x plus the ln of. Now if I take a look at this root x minus 1, I can write that as x minus 1 to the power of 1/2. And now you'll notice that there's a 1/2 here. So this 1/2 kind of acts like that b there, and that b can just be kicked to the front here. So my next line would be y equals to ln of x plus ln of, plus this 1/2 now comes to the front, so it would be 1/2 ln of x minus 1. So I just kick that to the front there. Alright, now that I've simplified this, now I can take the derivative now. So this would be y prime equals to, now the derivative of ln x, that's just 1 over x, plus, now over here there's a 1/2 here, so the 1/2 is a constant, so I can move that in front, times the derivative of this guy right here, and the derivative of that is going to be 1 over x minus 1, and the inside here, x minus 1 here, the derivative of x minus 1 is just 1. So if I wanted to simplify this, this would be 1 over x plus 1 over 2 times x minus 1 on the denominator, and that would be equal to y prime. So that's my final answer there, 1 over x plus 1 over 2 times x minus 1. So for these kind of problems, my goal is I want to simplify my expression by using pre-calculus logarithmic properties, and then I can use my derivative rules to simplify the answer. Okay, let's move on to question number 3 here. Now for question number 3, I want to use some of the logarithmic properties here. So if I have ln of a over b, which is the case in this particular problem here, because my a is like this x squared minus 1, and my b is this x squared plus 1. Now using my logarithmic properties here, if you're dividing, you can expand this by doing ln a subtract ln b. So let's go ahead and apply this logarithmic property to the original problem. So this would be y equals to ln of bracket x squared minus 1 minus the ln of bracket x squared plus 1. Alright, so that's using the logarithmic properties. And once you use the logarithmic properties, you can simplify your original expression, which will allow you to take the derivative a little bit easier. So my derivative would be y prime equals to, alright, there's a ln there, so the derivative of ln is always 1 over the inside function, and the inside function is x squared minus 1. And then the chain rule states that I need to find the derivative of the inside guy, and the derivative of that inside guy is just 2x. And then there's a minus sign. Alright, now the derivative of ln is once again 1 over the inside guy, and now the inside guy here is just x squared plus 1, so x squared plus 1, And then the chain rule states that I need to take the derivative of that guy, and the derivative of x squared plus 1 is 2x. So right there, that's your final answer, and if you want to simplify this, you can. You can move the 2x and multiply that with the 1, so 2x all over x squared minus 1, minus, and then 2x times 1 would be 2x all over x squared plus 1. So that is your final answer there. Okay, let's move on to the next question here. Question number 5 here. And once again, I'm going to highlight the inside functions because it seems like there's the two inside functions here being multiplied with each other. And we need to use one of the very first logarithmic properties here. So ln of a times b. And if I expand that, that's going to be ln a plus ln b. All right, so the a here is that, and the b here is the blue part there. So if I want to expand this, this would be y equals to ln of bracket 2x plus 1 to the power 3 plus ln of bracket x squared plus 1 all to the power 4. So that's how you can split apart the original question by using logarithmic properties here. And the other logarithmic property that I'll be using is when I have ln a to the power of b, and the rule is the b can actually just kick you can actually kick that to the front, so that'll be b times ln a. All right, so notice I have a power here, the 3 and the 4. I can now kick those to the front to continue using my logarithmic properties here. So this would now be y equals to 3 times ln of bracket 2x plus 1. And then plus, remember, we're not taking the derivative here just yet, so we're just using logarithmic properties to simplify our original problem. So we're not using the power rule here, we're just using logarithmic properties to simplify our answer. Now let's go ahead and take the derivative here. So this would be y prime equals 2. Now 3 is a constant, so the constant can remain. And then the derivative of ln is always 1 over the inside function, and the inside function is 2x plus 1. And then the chain rule states that I need to take the derivative of the inside guy, and the derivative of 2x plus 1 is just 2. And then plus, and then remember there's a 4 here, so 4 is a constant, so constants we can just leave alone. And then we got to take the derivative of ln. The derivative of ln is 1 over the inside, and the inside function here is now x squared plus 1. And then the chain rule states that I need to take the derivative of the inside guy there, and the derivative of that inside guy is just 2x. So the derivative of x squared plus 1 is 2x. Now we're almost done here. Now we just need to simplify this. So 2 times 1 times 3, well that's just going to be 6. So this will be 6 over 2x plus 1 plus. And then if I take 2x times 1 times 4, that's going to be 8x. So this will be plus 8x all over x squared plus 1, and that's my final answer as my derivative. Okay, let's move on to a few more. Okay, for this next problem, question number 7, I have a few functions inside the ln function here. So here's x, that's one function. So you can consider the x like your a. And then there's this guy right here. I can consider that part as being my b. And then on the very bottom here, you have another function there, which is kind of like your c. So if I go ahead and write out a ln property here, it's kind of like ln of ab divided by c. If I want to deal with the numerator first, I would expand that by doing ln a plus ln b. And then since I'm dividing by c, I can finish that off by doing ln c. So that's how I can expand this particular problem. So let's go ahead and expand this. So this would be y equals to ln x plus ln of root x squared plus 1 plus the ln of the denominator there, sorry, not plus, it's actually minus, so sorry, so minus ln of the bottom piece there, which is going to be bracket x minus 1 all to the power 2. So that's how I can expand that. And then what I'll do next is I'll continue to simplify this by writing ln of x plus, now this part right here, the root sign, I can write that as a power, so that's the same thing as ln of bracket x squared plus 1 all to the power 1/2. So remember, you can write the radicals as a power by raising to the power 1/2 minus, now since there's a 2 here, I can kick that to the front there using the logarithmic properties. So this now will become 2 times ln of bracket x minus 1. Now before I continue, before I take the derivative, I'm going to simplify this one last time. So this would be ln of x plus, now one of the reasons why I will simplify this one more time is because there's a power here and I can kick that to the front there. That would become 1/2 and then ln of bracket x squared plus 1 and then minus 2 times ln of x minus 1. Alright, so I've simplified that using my logarithmic properties, and now I can take my derivative. So y prime equals 2. Now the derivative of ln x is just 1 over x plus, now there's a constant here, so constants can remain, so 1/2 times, now the derivative of ln of something is always going to be 1 over that something, and that something here is now x squared plus 1. And then I need to take the derivative of that inside guy. The derivative of x squared plus 1 is 2x minus, well, now there's a constant here, 2, so the constant can remain. And then there is the derivative of ln, so using my green marker, here's ln. So the derivative of ln is always 1 over the something, which is now x minus 1. And the derivative of x minus 1 is now just 1, so that would finish that off. And we're pretty much done here. We just need to simplify our final answer here. So this is 1 over x plus, now this 2 and that 2 can cancel off, and then we just have this x multiplying with the 1, so that would be x over x squared plus 1 minus, and then I have a 2 here, and 2 times 1 is a 2, so this would be 2 over x minus 1. And that is my final answer for that problem.